Good evening and welcome everyone. My name's Taryn and I'm part of the programs team at Hornsby Library. Hornsby Council recognises the traditional owners of the lands of Hornsby Shire, the Darug and Guringai people, and pay respect to their ancestors and elders past and present and to their heritage. We acknowledge and uphold their intrinsic connections and continuing relationships to country. Tonight, we're thrilled to welcome Chris Nunn. Chris is a sustainability advocate and professional and has 22 years experience in sustainability with expertise in environmental law, green building design, and corporate sustainability strategy, among many other things. Chris will show us around his beautiful Asquith home, which is both Passivehaus and Green Star certified. This evening's event is a collaboration with a number of other councils, and I would like to thank Guringai, Lane Cove, Mossman, North Sydney, Ryde, and Willoughby councils for their participation and support. We'll also be joined this evening by my colleague Susie from Hornsby Council's sustainability team. We will have time for questions at the end of the talk, and you can type them into the Q&A box on your screen. Hello, Chris, and welcome.
Hello, thank you. Thanks for having me, and thanks everyone for joining. I'll just share screen and we can get into the presentation. All right, well, thanks again. Budjiti Malinawal, which is good afternoon or good evening in the Eora language of the traditional custodians. I also pay my respects to traditional custodians and Aboriginal people here online and their elders past and present, and acknowledge that we're on Guringai land up in the north. So a bit about me. I'm 46. I worked as an environmental lawyer, then sustainability consultant, mainly in green buildings. And then for the last 7 years, I worked as the head of sustainability for a big property company. This is my wife, Maylin, on the left. She's originally Canadian, but moved to Australia after we met when we were studying in London. We've got 3 kids. Frankie, our girl, who's 8, Axel in the middle, who's 6, and then Zachary, our boy, who's just turned 3. And we moved to the area in about 2016, and I grew up in Sydney. I'm Australian, and I grew up in Chatswood West, so not too far away, near Lane Cove National Park. And when it came time, we lived in a flat in a city, and we'd had our first child, Frankie, and she got to the age of 2, and we decided we wanted to get a family home. And so we started looking around, and we found Asquith, which wasn't an area I was super familiar with before, but of course knew Hornsby. And yeah, it was just close to a train and close to bush. And, you know, it was a place where a block of land where the house was still just within reach of our financial means at the time. And I mean, most people here are likely from the Hornsby or surrounding areas, but you know, it's about 21 kilometres north of the city of Sydney. About 47 minutes is my commute from Asquith Station into Wynyard. And about 35 minutes drive if you've got no traffic, but you know, with traffic it could take longer, but I don't commute by car, so I'm not worried by that. And importantly for us, it was close to the bush, just 10 minutes to the beautiful Bobbin Head, and you know, not too far down to the lovely Crosslands as well. And we chose the house because it was within walking distance of a train station. I made these maps of all of the train stations around Sydney, and my family still lives in Chatswood West in the home I grew up in, and my sisters are in Sydney, my older and younger sister, and I kind of wanted to be in the area. And so I looked at what could I afford that was within walking distance of a train station. So being close to the train was really important to me. It's just a 4 or 5 minute walk, and I've run it in about 3 when I'm late for the train. And you know, most people here will probably know all the lovely things about the area, but it's got great shops, parks, great access to bushland and waterways, really lovely schools. Our kids are at Asquith Primary, gym. You know, we both do CrossFit down at Asquith, and you know, we love getting out in nature on the river in the canoe, and you know, out for bushwalks and things. And I do mountain biking, that's my hobby, and you know, we love swimming at the Hornsby Aquatic Centre, and got kids do swimming lessons there every Sunday. So you know, we love the area and we're really settled in here. So we chose this house. We bought the house in 2016. It was a 698 square metre block, about 18.63 wide and 37 and a bit deep. So a nice, good block. It's north facing to the front. So from a conventional passive solar design perspective, it's optimal to have the north to rear into your backyard. But we thought not to worry. It's a great block. It's close to the train station. That's the main thing. And we'll figure out the design to optimize the solar orientation if we ever get the chance to knock down and rebuild. but it was a sort of 1950s era weatherboard cottage, and it had asbestos in the back of the house, in the kitchen, in the bathroom, and the whole shed out the back was made of asbestos. So, you know, it was just, you can't really touch it without doing a major sort of asbestos removal project, which we're okay with. We went in knowing that that had been identified in the purchase process. And this is it, you know, pretty typical of the area, a small, you know, 1 bathroom, 3 bedrooms, living space to the front there with the stripy awning. That's the living room, and a dining room, and then a kitchen behind, and a couple of small bedrooms at the other end. And yeah, as I said, we lived there from 2016 and we're very happy there. And yeah, really grew to love the area, but always had the dream to build a house. And my wife trained in sustainability as well, so the two of us were always hoping to build a sustainable house, but didn't know if that had ever come to fruition. And we started the planning process soon after we moved in 2016, and engaged an architect and got some plans drawn up, and, you know, understood the setbacks and the planning regime. You can see the sun path diagram in the bottom right there, showing, you know, where the sun comes up and where it sets. And, you know, you do get lovely morning sun and afternoon sun into the backyard, particularly in summer. So that south facing backyard is not actually a real problem. In fact, we would almost choose that now, in that you get a lovely cool, in the heat of summer, the house shades a lot of the backyard, so you're nice and cool, and you've got the shade to play in the backyard. And if you want sun, you can always just pop into the front yard, because it's got a pretty significant setback, you know, almost 10-meter setback at the front. So the plans we came up with looked like this: 270 square meter internal area, 5-bedroom house. It's got 4 bedrooms. It's got 2 main, 1 little WC on the ground floor, plus a WC, a toilet, ensuite, you know, guest bedroom on the ground floor. And then it's got an ensuite in the master bedroom and a toilet upstairs for the kids. It's got a ground floor living space and a rumpus room on the north corner. And it's got a study down on the north side as well for me. That's where I'm now. And it's got a little gym room as well, because we're both into fitness. And it's got the garage on the side. And you know, the plans turned out pretty true to form. So there's the finished product. I took that today. It was a bit of a grey day, but you can see that it really does look exactly like the design, which is always pleasing. And there's one of the more architectural photos that we've had taken. It's a timber-clad building, timber frame, well insulated. It's Passivehaus certified, and it's the first Green Star Homes rated building in Australia. And why it's a sustainable house? Well, we pursued Passivehaus certification, which is a German best practice green building rating system. And part of that, we went for the highest rating. There's Passivehaus Classic, Passivehaus Plus, Passivehaus Premium. There's actually only 17 Passivehaus Premium buildings in the world at the time this was built. And that involves a slightly higher level of energy efficiency than the regular Passivehaus, which is already a very high standard of energy efficiency. So we went a bit above that to get Passivehaus Premium, and the addition of solar, which in Australia is great. We've got a 20 kilowatt solar system, and that means it's net zero carbon, net zero energy and emissions. It produces more energy from the solar on the roof than we use over the course of a year. I mean, there's times at night when we've got the lights on and hot water heating systems going, and we're having showers and baths for the kids, that it is in deficit, but it's connected to the grid. It's drawing from the grid at those times. And then during the day, the big 20 kilowatt solar system is exporting about 3 times as much energy as we use out to the grid. So notwithstanding that we buy energy, you know, like everyone, 28 or something cents coming in, it's like 9-10 cents going out, because the solar system's so big and it's pumping out about 3 times more energy than we use. We net out and we don't have energy bills. So our energy bills are actually credits. We have not paid an energy bill since we've moved into the house. And we're into the rest of the sustainability features as well. So we thought about waste, obviously recycling and general waste, but we've also got a compost bin built into the kitchen benchtop and compost, and you know, it's all integrated in the kitchen joinery. I mentioned it's super close to transport, and you know, we've got a Nihola, which is a cargo bike that, you know, we take the kids to school in and daycare, and it's set up. We don't have an electric vehicle yet. We're saving up for that one, but it's configured so it's got 3-phase power and an electric vehicle charging station, ready in the garage. And we've got the electric bike, and we've got a Prius for our main vehicle, so we'll eventually retire that and buy something electric. So it's made out of timber. It's a timber frame. It's Forest Stewardship Council certified laminated veneer lumber as the frame, which is nice and true and straight and square, and low carbon as a construction material. It's got WeatherTex cladding. WeatherTex is a panelized board. It's manufactured up in the Hunter, and the guys who produce it, they're a timber sawmill company, and they saw logs, and then the pulp that is the waste product from the milling process gets collected and combined with 3% paraffin wax and then pressed under heat into these panelized boards. So it's a little bit like masonite, that kind of dark looking fiber board that you might see, but it's very weather resistant, and clearly it's painted on the outside, so that's means it doesn't degrade over time, but it's a really resilient but very low carbon, local, sustainable timber waste product. So it's super sustainable, very low carbon, and it's a circular economy story around reusing a waste product. And we like it. It's nice that it's wood, and we like that. We aim to grow food. We've got mandarins and lemons and herbs and fruit trees, and I've got a beehive on the roof. I haven't got my bees yet since we moved back in, but we've got lots of food growing, and eventually we'll do honey production and native bees as well. We've got the rainwater tanks under the driveway, and we've got a grey water reuse system that captures water from the showers, and then it puts it into the rainwater tank. So we've got grey water reuse, flushing the toilets, and for the irrigation system as well. It's got a green roof above the garage, above the shed. And we do lots of this kind of thing where we have people through the house and promote a culture of sustainable living and show people the house. And it created lots of local jobs along the way. The frame was manufactured a modular prefabricated construction system built in a factory down in Victoria. Local builder Jamie Graziano, local architect. So we're pleased that it sort of created skills and jobs in the area. It's also designed and built to the Livable Housing Australia standard, which is a standard for wheelchair accessibility or universal design, as it's sometimes called. And so the ground floor is accessible. It's got level access through the front door, and the guest bedroom on the ground floor at the front is designed so that it could be an accessible bedroom for someone with special needs. Not that that's something we have to grapple with now, but we're thinking about our respective parents and them aging with us here, and us ourselves aging in this place toward the end of our lives. So we're definitely sort of thinking long term into the future. And it's super healthy and comfortable, which is really the main reason for doing Passivehaus. Passivehaus certification means that it maintains a stable temperature between 20 and 25 degrees internal temperature passively, hence the name Passivehaus, through the insulation, the glazing, the air tightness, and the mechanical ventilation system that maintains that beautiful, stable, comfortable internal temperature. And there's a ventilation system constantly providing fresh air to every room and then extracting it from bathrooms, laundry, kitchen through this mechanical ventilation system, which has a heat recovery unit. So that means that it's supplying fresh air continuously, but it's doing it in a really efficient way. So you're not bringing freezing cold air in from the outside in winter. It's being tempered or pre-warmed by the outgoing stale air from inside that's constantly being turned over at a rate of 30 litres per hour, or 8 litres per person per second. So it's a really nice feeling of freshness continuously inside, and you never get that sense of stuffiness or staleness or the idea that CO2 can't build up, etc. And it's got active play areas out the front and the back, and swings, and a cubby house and a trampoline, and we're big on interaction with nature, so it's got a green roof and lots of primarily native plants. If it's not a food plant, then it's a native plant. So what did it all cost? We bought the site in 2016 for just over $1 million, which is a huge amount of money, but is actually looking like pretty good value based on today's market and where prices are now in the area. So that was just affordable for us back in 2016. And then the construction contract was about the same again. And then there was architectural fees, surveys, etc. And then some variations and landscaping and, you know, planter beds and paths and things that added a bit of cost. So we ended up spending, in terms of buying the land, demolishing the existing house, and then constructing the new house, and right all the way from beginning to end, it was $2.3 million in total, which is a lot of money. But, you know, we've had the place valued and it's probably above that. It's probably 2.4 to 2.7 now. So, you know, even though we built arguably one of the most sustainable houses in the world, and, you know, went a more expensive route than a traditional, you know, volume builder, by having a bespoke architect, a bespoke custom builder, and certifying it to the Green Building Council standard, as well as the Passivehaus standard and the Livable Housing Australia Universal Design standard. We've really gone all out, but we're still ahead, you know, financially. So we've got a healthy, comfortable house, which is zero net carbon, no energy bills. And, you know, in the end, we're still doing pretty well from a financial perspective. And so what did achieving the Passivehaus certification cost? A lot of people want to know what's the difference between a normal house and a sort of greenhouse. We've done some studies on this, and it wasn't more than a similar architect designed custom build. It was a lot more than a volume build house though. So it ended up being about $4,000 a square meter, which is not unusual for a custom designed architectural high-end house. But most of the cost difference between a volume builder, which might be $2,500 to $3,000 a square meter, versus the $4,000 a square meter, most of the difference in that cost is about having a custom architect, custom builder versus a volume builder and a standardized design, where you're getting economies of scale, the repetition of many examples of that standardized design gives economies of scale to volume builders, and they can deliver the product at a lower cost. But you build a one-off product that was designed by an architect and is built just once by a builder, and a small scale builder at that, who just does a few houses a year, a couple of 2-3 houses a year, then yeah, your cost goes up. And so the bulk of the cost difference was about having a custom architect and builder, not about the Passivehaus. And so what are some of the differences with Passivehaus? So the cost elements that are different are that you have one of these machines on the top right, which is called a mechanical ventilation with heat recovery unit, which is connected to a fresh air supply, and then it takes the air through that box, which has a heat exchanger and a fan in it, driving the air through this heat exchanger. It supplies it via a series of tubes into all the rooms via the ceiling, so into all the bedrooms, and then exhausts pull it back from little ducts in the ceiling, in the toilets, in the kitchen and in the laundry, and then it goes back through the machine and then out above the green roof actually. But that process of constantly providing the fresh air is what's special and different about a Passivehaus, is it's got a mechanical ventilation system. You're not relying on your fresh air to come from opening the windows and doors or leaks through the building fabric. It's constantly giving you fresh air with that machine. And it's filtered fresh air, so there's no pollen, dust, etc. And in order to make that efficient to run a machine constantly providing fresh air, the Passivehaus standard encourages airtightness. So it means that there's no leaks in the building fabric. So that's the picture on the bottom right. You can see the white airtight membrane, and the way that those panels have been joined there is with this special tape, which is airtight as well. And that creates a seal so that when it's too hot or it's too cold outside and you want the air conditioning on, or you want just to be, it's a 40-degree day outside and you want to preserve the nice 22-degree indoor air temperature that you've got, then you can, because it's not constantly leaking. Any energy you put into this house, 98% of it stays in the house because of the efficiency of the mechanical ventilation system. It doesn't leak out through cracks. So you're not constantly throwing more energy into the air to stay warm and comfortable. You're constantly getting fresh air, but the heat exchanger means you don't lose the energy that you put into the space. The other big thing is windows. So in Sydney, we've got double glazing, and in Melbourne, you might even have triple glazing in a Passivehaus. And they're timber frame, so there's no thermal bridge effects. And what that means is that in a conventional, say, aluminium profile window, it's just a profile of metal. And that means that when the sun hits the outside, the heat radiates through that frame, and dumps heat into the space in summer, and likewise in winter, the heat gets sucked out of the inside and pushed out through the frames and single glazing in a lot of cases. So the windows are much more high performance. It's got an airtight membrane. It's got a mechanical ventilation system, and it's also got improved insulation. So they're the main sort of physical differences between a passive house and a regular house. And because we did this, we got preferential finance. We got a loan from Bank Australia, who have the Clean Energy Home Loan, which for qualifying houses above 7-star in the NatHERS, the National Australian Home Energy Rating Scheme, or a passive house. And we were the first passive house to apply for this loan in Australia. So we got a preferential rate on our mortgage. It was 0.6% off the standard variable rate interest rate at the time, and back in 2016 or rather 2019 when we took the loan out, that was a really good deal. And we've got a fixed mortgage, but it's a discount on the fixed mortgage as well by having this passive house. So there is sort of a financial reward for doing the right thing and building a green home, and other banks now have similar products as well. So the timeline of the story, we started the process in 2016 when we bought the site. We briefed an architect later that year and got some concept designs done. But then eventually I wasn't super happy with what that first architect did, because they weren't passive house trained. So they produced something that I wasn't in the end happy with. So I kind of went back to the drawing board and researched volume builders and got to the point where I'd put a deposit down with a volume builder. But then again, wasn't happy that they couldn't deliver passive house. So we saved up some more money. I did a whole bunch of sketches and research and drawing and thinking about how I could make this house into a passive house. And I got a report from a passive house certified designer saying, yep, it would pass if we built my design. And then based on a big process that I'd been through, I then briefed an architect who is a passive house certified designer. And then he did some concept sketches. And then we did the concept design and the landscape plans, and lodged our DA in 2019. And then in 2020, construction proceeded from sort of the beginning of the year. The DA was approved in February, and the builder actually started on site in, I think it was July, August in 2020, mid-2020. And then construction certificate was granted, and there we are. Construction started in September, and the demolition October, they poured the slabs, and then it was November that they actually erected the frame, and they sort of taped it all up in December and installed the windows and facade in December and through January, February. And then March, we got the solar panels on, and April, they did all the finishes, the electrical and plumbing and plasterboarding, and then it was finished in June. So it took about 9 months from beginning to end of the construction process, and we were in sort of mid 2021. So we've been in for about a year. So this is the family when we moved to Asquith. You can see our daughter Frankie, who's now 8, was just a baby girl. She was only 2, and we had Axel on the way. But we lived in the house for a good 5 years before we demolished, 16, 17, 18, 19. And now we've got 3. And it was typical of a family, moving to the suburbs. We didn't have a bath in that house. It just had a tiny little 1 bathroom with a shower in it. Didn't have a bath, so we were bathing the kids in the sink and in this little tub in the bottom of the shower. It was pretty funny, but it had a lot of problems, that old house. I had put temperature sensors in, and in summer, this is the summer of 2020, it was 36 degrees in the bedroom, inside. And a lot of the time during summer, it was in the sort of 30 degree to 35 degree range, which is way too hot. And most of the time, most of the summer, it was above 25 to 30, often 27, 28 inside. And then sometimes it was in the sort of comfortable range there in green between 20 and 25 on cooler days. But it was really about the weather. Whatever the weather was outside, that's what we were feeling inside. And here's the summer of 2019. The previous summer, it got to 35 in the bedrooms and 32 in the kitchen, and peaks of, way above 30 degrees inside. Lots of times. This is a month in summer. I think it's January through to February 2019, which was, a hot summer. But it was mainly way too hot inside in summer. And that was 2018, the year before. And sometimes in a cold year, even in summer, it, as per the weather, it was getting down below what's comfortable, really. And of course, in summer of 2019, late 2019, early 2020, we had the massive bushfires, and you know, as everyone who lives in the region knows, there was a lot of smoke around from fires, whether that was back burning or the actual out of control bushfires. And it brought really bad internal air quality. We were breathing a lot of smoke and particulates in our indoor environment. And then, of course, in the winter, it was cold. It's 6 degrees, 6.6 measured by this temperature sensor at the time outside the old house. And then inside it's just 12.6 degrees. You know, this is, you know, Tuesday afternoon at 3 o'clock in the afternoon. It's 12 degrees inside. And we got the heater on. This is in the living room. The heater just cannot maintain the temperature because it's single glazing. It's an old house, uninsulated, and you just cannot stay warm inside in those conditions. You have to really rug up and it's not comfortable. And it's not comfortable for kids, you know, like kids watching TV in the winter on the couch, you know, had down jackets on and sleeping bags and really rugged up, right? And we had this 2000 watt electric heater, which cost a bomb to run, but it just could not keep the living room warm. You know, we only really warmed the living room in winter and then the kids' bedrooms at night in winter. But it was very expensive to do that and it was ineffective. Like it was really uncomfortable. And that's sadly typical of Sydney houses, particularly old houses. And so this is the winter temperatures, you know, almost all of the time it's below 20. So it's uncomfortable. You know, it got down to 10 degrees inside. It was quite often 15 degrees inside. And, you know, this is the previous winter, 2018, and mostly 15 or 20 degrees and 7 occasionally. And of course, all that cold and single glazing means that you get condensation on the windows. And, you know, this is Frankie's bedroom in the morning. She wakes up and, you know, it's condensation all over the windows, which trickles down and, you know, sits there and creates black mold. You know, all around all the window frames in the old house had black mold. And it doesn't matter how many times you clean it, it just comes back because condensation happens when warm, moist air from our breathing meets the cold surface of the glass, forms condensation, the moisture comes out of the air, trickles down the windowsill and then accumulates and then ultimately forms the conditions for mold to grow. And certainly that was true. This is during the demolition, we got to look up into the ceiling void and above the bathroom, the insulation was full of black mold. It was horrible, you know, and that's what happened. And of course it was expensive to do that and to heat and cool this building, really inefficient, old, poorly insulated, single glazed, leaky house, cost a lot. There's the old electricity meters and there's the energy costs in kilowatt hours per day. And you can see that, you know, during winter, you know, it got quite expensive. You know, you're spending a lot of money to keep things warm during those very cold months, which averaged about, you know, over $2,500 in electricity bills a year for a really small house. Anyway, so we had a lot of problems. It was too cold in winter. It was too hot in summer. It was just impossible to keep it cool or keep it warm due to the leakage through the building fabric, through the cracks in the floorboards, uninsulated floorboards, you know, brick piers down to a void below. You know, you could see daylight through the floorboards, which is a classic older house. And then we got condensation and mold from the single glazing and the poor quality aluminium frames. And we had a lot of black mold in the house, which was unhealthy. And we had very high energy bills and it was super inefficient. So, you know, I'm a sustainability person and I knew about the Passivehaus standard and I really wanted to build a Passivehaus, but I just wasn't sure if we could afford it and we could find someone to do it. Because in 2016, there was only 4 registered Passivehaus architects in New South Wales. And nobody had any local experience building them because there wasn't one in New South Wales at the time. But my wife and I met when we were in London. We studied over there and we lived over there for about 6 years. So it was something we discovered when we were living and working in Europe. And, you know, but it was still relatively new to Australia, even though it's been going in Germany for more than 30 years and in the UK for 20. In Australia, it's still pretty new. So yeah, we hired an architect and that architecture firm had one Passivehaus certified architect in the team, but the lead architect was not. And she produced these drawings, which were not really consistent with achieving a Passivehaus outcome as the initial concept sketches, and then modified them when we said, okay, well, we really want a Passivehaus. So we redid it and it was a much more compact form, which is what you want in a Passivehaus, not too many corners, not too many places to tape up and seal. She produced this good design, but we got it quoted and it was pretty small and it was going to be well over $1 million. And we just were like, oh, we're not sure. So we pressed pause on that. It was going to be more than $5,000 a metre squared. And we just said, look, I don't think we can afford that. And we pulled the pin. And so I sort of went back to the drawing board and researched, could a volume builder, build a sustainable house for us? And we researched all of these different, volume builders. I looked through thousands of off-the-shelf standard plans to find one that would suit, a wider block and use the width of the block. And I looked at all of these, and these were kind of my final selections, which were all good and would have been okay on the house, on the block, and got to one in the end, this one, the Montgomery Newport 270 square metre house, which I thought would work quite well. Not too deep plan, didn't want to take up too much of the backyard, wanted to preserve space at the back, so relatively compact shape. And then I got out my pen and said, right, well, we want to make it even more compact and put the garage on the outside of the thermal envelope and not have a cold uninsulated space forming part of the main house. And we got a quote on it, and they initially quoted just over $400,000. And then we paid a deposit to go further down the track, a refundable deposit. And they eventually quoted my modified design, which was this one, for about $480,000. But I was advised by lots of people in the industry that you need to add at least 30% based on the additions that you're going to encounter along the way, driveways and landscaping and curtains and all the things that are not in the base quote. In order for the volume builders to be competitive with each other, they exclude a lot of things from their base quote. So everyone says, look, realistically, it's going to be at least 30% more than that. So I was thinking, okay, it might be $700,000 or $800,000, $2,500, $3,000 a square metre, but they couldn't do Passivehaus. So we got to the end of the process and I said, no, I'm sorry. If you can't do Passivehaus, I'm going to go and do something else. And I got my deposit back. And then I was just committed. Okay, right. I'm back to the process of getting a bespoke architect and builder. And this is what Passivehaus is. I mean, it involves, improved insulation, better windows, fresh air supply through a mechanical ventilation system, air tightness of the building fabric so that when you close the windows, you can of course use a natural ventilation strategy and open the windows, open the doors and benefit from natural ventilation. But when you close the windows, you get efficient heating and efficient cooling because it's not leaky. That's really what the air tightness is about. It's about avoiding drafts and leaks that are a key source of inefficiency in terms of heating and cooling. And then, of course, there's no thermal bridges or reduced thermal bridges so that you're not getting heat leaking out in winter through your frames of your windows and your doors. So I literally went back to the drawing board after that process and did lots of SketchUps on graph paper and eventually got to the point where I designed a three-dimensional concept in a SketchUp model and populated it with all the furniture and things that we have and got to this design. And that's what I took to the architects and they were really accommodating of that and drew it up and basically we costed that and off we went. So this was the concept design. It looks a lot like my sketch and 3D model, and these are the architectural plans. So it's got a kitchen, living, dining at the back, south facing, a big living space. It's got a gym room. It's got a study on the northeast. It's got a guest bedroom on the northwest. And then it's got the big shed garage to the western side, which actually provides a lot of sort of thermal buffer. Doesn't get a lot of hot sun hitting the western side of the living spaces. And then upstairs, it's got 3 bedrooms for the kids. It's got a rumpus room. And it's got the master bedroom, which has a walk-in robe and an ensuite. So pretty similar design to a lot of what the volume builders are designing as well. So there's the north elevation on the top and the rear elevation on the back. And we used a modular prefabricated wall and panel system built by this company Carbon Light out of Victoria, which has insulated roof panels, insulated wall panels, and insulated floor panels. And it's manufactured in a factory in Victoria. These are the jigs. They sort of computer numeric control the timber cutter, and then they bring the timber in here and manufacture it into panels. And then those panels, it's all 3-dimensional, very detailed design right down to each stud and noggin. They know where it is. They have numbered sequences in order to fabricate them and then numbered onto the truck and then numbered to come off so that it's all in a really efficient construction sequence. And so you can see them here, that panel 14, 13 and 10 on the panel, on the pallet, ready to be trucked. And here are the roof panels that get lifted up. And so this is a bit of a time sequence. We had a time-lapse camera taking photos, and there's actually a YouTube that the link's at the end, but you can see the time lapse of the construction sequence. So demolition happened. That's the old house coming down, and then the asbestos was stripped out first, of course, and then the demo happened after. So that's why the shed is sort of naked on the outside, because with asbestos paneling, and all the asbestos has been removed from the back of the house as well before the demo happened. And then level site, and then they dug the foundations for the new house. It was a slab on ground, and that was done because in summer there's a real cooling benefit of the big thermally massive slabs sitting coupled with the ground. That's a free cooling effect, because any excess heat in the house goes down through the slab and sort of is evacuated into the ground, if you like. And then here's the plumbing going in, about to pour the slab. So there's the slab for the house, and then here's the slab for the shed on the side. And then scaffolding goes up, and then you can see the pallets arrive with the prefabricated internal and external walls. The blue wrap is on the outside is a weatherproof membrane, so it's really watertight. And then there's a white membrane on the inside of the panels, which is an airtight membrane, which gets taped up, and that forms the airtightness barrier, which means it's so efficient. And the panels went up in just 3 days. So the house was a slab, this is sort of day one, and then they go 3 days of craning the panels into place and connecting them. You can see the white airtight membrane comes round from the ground floor around the floor cassettes and joins to the airtight membrane on the top as the panels are placed on the first floor. And then here's the walls going on, the internal stud work and the attic cassettes, and then the roof panels going on. And the whole frame was erected from slab to that in just 3 days, Monday, Tuesday, Wednesday. And then it torrentially poured on the Thursday, and it was waterproof. Like, even at that point, we were not getting any leaks in the house, which was incredible because it hadn't been taped up yet. And so here's the garage being built. It's timber frame as well. And here's the windows. They arrived, similarly, they were manufactured in Poland, procured through a company in Canberra that then trucked them to site in a pallet. And so when the frame was ready, the windows were installed, and then the cladding goes on. You can see those vertically oriented sort of weatherboard panels going on there. And then here's the membrane over the shed roof going down. It's a waterproof membrane on fiber cement sheeting to make the sort of underside of the structure waterproof, because obviously you're going to have a lot of moisture sitting on top of it with a green roof. So then they put these storm cell down, which provide drainage underneath the growing medium, which is that sort of yellowy, almost looks like insulation. And then there's a pile of dirt, about 5 to 10 centimeters of dirt on top. And that formed the green roof. And then here they are doing the solar panels. 20 kilowatt solar array goes on, and there's nearly finished. I think it's about April 2020, with the solar panels on, the cladding finished, the paint done, and then just doing the external paths and driveway. So this is really what the walls are made of. It's laminated veneer lumber, which for the frame and the studs with insulation in between. And then on the inside, there's an airtight membrane, and wherever there's a join in the sheets of this membrane, you tape it with a special 100-year duration sticky tape that's also airtight, and that creates the airtight membrane. And then that's all done in the factory. The taping's done on site, but the membrane's fixed in the factory. And then the studs are also on in the factory, and that gives a services cavity to run the pipe work and the electrical cabling. And then on top of the cavity is the plasterboard, so that if you put a hole through to put a picture up, you're not going to puncture your airtight membrane. You've got a 4 centimeter gap between the back of the plasterboard and the airtight membrane, but you do have to not put a drill through it. And then on the outside, there's the same, the laminated veneer lumber stud work, the insulation, and then the weather resistant barrier, the waterproof membrane is on the outside. That came in from the factory and then was taped in place. It's also got battens on the outside, and then onto that is fixed the cladding system. And you could do any kind of cladding system. You could do brick, you could do fiber cement, you could do terracotta tiles, you could do any sort of external render, whatever you want, to create the finished product. But we chose this timber WeatherTex. The real smarts is in the middle of the fabric. And then of course the windows are a special. They're high performance, you know, German sort of specification, manufactured in Poland, tilt and turn windows. So they've got these three positions, closed. And then if you turn the handle all the way up, you can see that it tilts and gives you a little crack at the top. So you can get some nice background ventilation, even if it's raining and you don't get wet. And then you can open it fully like a normal window, full opening. And this is a cutaway of what the windows are like. So they're timber, double glazed, insulated spacer between the double glazed windows, and then aluminium cladding on the outside for, you know, fire protection for the frame. And it's much more durable really to have these aluminium frames on the outside of the timber, which is great because they're thermally isolated. So they're not causing that thermal bridge effect, transporting heat in or out of the building. You can see that they're attached to the wood with a rubber connector, so that they're thermally isolated from the timber frame, and then the timber itself is full of air pockets and acts like an insulator, and so you're not getting any leakage of heat in or out of the building. And this is a sort of thermal analysis of the top one is like what happens in a normal steel or aluminium profile frame. You know, if it's hot outside, you know, 34 degrees outside, a lot of that heat's coming through, and the frame and the glazing is acting like a radiator, radiating that summer heat to your inside through the frame, because the metal conducts the heat to the inside. Whereas in a thermally improved or thermally broken frame, there are gaps in it and you cannot transmit the heat through. And so you can see it's 34 outside and inside it's 20. And that's what happens in a passive house. It stops the heat transfer in summer, and it stops the reverse effect in winter. It stops your carefully, managed internal temperature with your heating system. It's not all leaking out your windows and cracks. It stays in. So this is the WeatherTex. It's wood fiber cladding. It's 97% recycled Australian native hardwood timber offcuts and 3% paraffin wax. It's zero carbon. It's non-toxic, low VOC, Forest Stewardship Council certified, warranty, watertight, termite resistant. It's actually BAL 19 fire rated as well. We're not in a flame zone or BAL rated area, even though we're in Asquith and we're relatively close to the bush. It wasn't a planning requirement that we had extra fire protection for this house, but I was thinking about bushfire when we designed it, and I was originally thinking fiber cement, but because that's really high carbon, we opted for the much lower carbon sort of recycled timber cladding system, which is a much more sustainable option. And then in order to provide extra resilience in the case of a bushfire, we actually put an external mounted sprinkler system on the outside of the house so that it can be wet if we have to evacuate in the event of a fire. I'll have some pictures of that later. This is the sort of heart or lungs of a passive house. It's a mechanical ventilation with heat recovery system. So the sort of grey tubes bring air from the outside. So you can see the top left. This is a sort of winter scenario where it's cold air coming in from the outside, going through a series of fine tubes that don't mix the air, but they pass in close proximity to each other, so that whatever warmth is left from the house inside is transferred to the incoming cold air, meaning that it gets warmed up before it goes through the distribution system, the ventilation system to each room. So it's pre-tempered in winter and it's pre-cooled in summer by the latent heat in the air that is being exhausted out continuously. So because the fan's constantly moving air in and out, there's this constant heat exchange effect, and that is really efficient at keeping the heat in winter and keeping the nice cool temperatures in summer. And it also is continuously removing moisture from the air, because as the stale air is constantly pumped out of the building, it's carrying the moisture from our breath and from laundry and showering and clothes washing and dryers and things. It's carrying that moisture in the air as humidity, which is getting caught in a sort of a drain that drains down under the mechanical ventilation system. So it means that it's not getting humid inside either, because that moisture is constantly being transported out of the building. So this is our mechanical ventilation system. It's got an acoustic silencer on the top and space for a HEPA filter. It runs 24/7, so it's always providing continuous supply of filtered fresh air to every room. Doesn't matter what the weather is, we've got nice fresh air. Approximately 30 meters cubed of air per hour for each person. And the entire volume of the house is changed over at least once every 3 hours. And this prevents the buildup of airborne pollutants and keeps indoor air pollutants like CO2 from our respiration and particulates and dust and other sort of indoor contaminants. It keeps that out of the house. It is continually exhausting that stale air out. It has different modes, but it normally just operates at a normal rate, and it uses 40 watts. So it's the equivalent of an old low wattage incandescent bulb, or the equivalent of a halogen fluorescent light, one light. So it's constantly doing fresh air for your whole house with the equivalent of a light bulb's worth of energy, which is tiny, really, given what it's doing for your health and for your comfort. And that's more than balanced by the energy efficiency it saves in terms of heating and cooling. So the ventilation system, our one, you can see on the photo on the right, it sits in a cupboard in the laundry, takes up space of about the size of a small fridge. But yeah, it's just tucked away in the laundry and it just does its thing, continuously providing fresh air to the house. And that's really one of the secret ingredients of a passive house, is a mechanical ventilation system. So you can sort of see there, this is how the mechanical ventilation system distributes the air. This is before it was all connected during construction, but it pumps air up through those tubes that get dispersed into every room and supplied through these little vents in the ceiling, and then returned from the kitchen and laundry and toilet. And what that does is it means that you don't get CO2 and indoor air pollutants building up. And this is a sort of graph of what happens at various levels of CO2, but the normal background rate of CO2 is 400, and in houses it is quite typical for it to get 500, 1,000, 1,500, 2,000. And that causes, fatigue, poor concentration, breathing difficulties, headaches, and poor concentration. And the higher you go in the concentration of CO2 in the air, the more proportion of the population starts experiencing these adverse health effects from CO2 and other indoor air pollutants. And so this is the fresh air rate that corresponds with, good air quality. It should be around 8 litres per person per second. And that's what Passivehaus delivers. It delivers sort of 8.3 or 30 litres per 30 metres cubed per hour. And that means that it's the equivalent of what you'd experience in a high-end office. It's a nice continuous supply of fresh air that means you never feel stale or stuffy or uncomfortable. And that means you have better concentration, you sleep better, and you don't suffer from drowsiness and headaches and the other things you can get from indoor air pollution. And this is a study of 29 buildings in Australia. Most houses in Australia are naturally ventilated, and you can see the blue humps are a whole year for one house. And the blue humps represent the CO2 in the air over the course of a year and how much at various times. So you can see the peak of a lot of the humps is on the right-hand side of the blue vertical line, which is the 1,000 parts per million. So a lot of houses are operating all the time over 1,000 parts per million of CO2. And some are even spending a lot of time above 2,000. You can see there's one outlier that spends almost all year up in the 2,000. That's unhealthy, that's bad for you. But the Passivehaus is the one down the bottom, and it keeps the CO2 in the indoor environment to well below 1,000, much more like background levels of 400 or 500 most of the time. So that's what Passivehaus does for you. It means you don't get indoor air quality problems. And there's no drafts because it's airtight. The air supply doesn't feel like there's air moving. It's carefully calculated so that it's just enough to be comfortable, but you're not going to notice a perception of a draft. And it's really quiet. You can put your head right next to that machine and you cannot hear it running. It is super quiet. And the air distribution, there's no noise from the ductwork or no sort of whooshing sound of the air through. You just do not hear it. It is absolutely silent. And it's got filters, so it's constantly filtering out any dust or pollen or particulates or bushfire smoke in the air. So you get a very healthy indoor environment as well, because none of that stuff is coming inside. And it also removes odors as well. So it always smells nice inside. And so we added a sort of special additional unit to the mechanical ventilation system, which is called a HEPA filter, a high efficiency particulate air filter. And that screens out even the worst of the bushfire smoke. So we can open this little flap at the top where the red arrow is and insert this enormous filter during a bushfire event, and we will not get smoke inside, and we'll be breathing easy inside while, you know, unfortunately the outside air is going to be actually really bad for your health. You know, there's studies on what happens when you have, you know, that level of smoke in the air, and it's really not good for your lungs. It's like the equivalent of smoking, right? It's not good for you. And so that's how a HEPA filter works. I won't get into that, but you can sort of see the white membrane behind that. That's Andy, the architect, the tall bloke, and the other gentleman is Jamie, the builder, sort of, you know, discussing the plans. But in the background is the airtight membrane. So that's the white airtight membrane by Proclimber, which is a company which makes this stuff. And that membrane's called Intello. And it's a really high-tech piece of fabric, effectively, that will allow moisture to come out of the fabric, but it will not allow air through. So it's quite a technical fabric. And then the black tape that you can see on the left-hand side is where the two panels have been joined, and the little cross tapes are where they've had to screw the studs together, and the tape keeps everything you know, airtight continuously around the fabric of the building. And this is what it looks like where there's a penetration, where the electrical services and plumbing services come through the wall. You have to tape that up and seal it properly so that there's not a leak during every penetration. So you don't want to punch holes in it. And part of Passivehaus is that you get a blower door test. So this red thing is a temporary little bit of fabric that goes into the door frame, and then there's a fan running that pressurizes and then depressurizes the house, and it's got to hit a certain level of air tightness, 0.6 ACH, or less than 1 meter cubed per meter squared per hour leaking out, which is tiny. It's the equivalent of like a hole the size of a 20-cent piece. It's got to be that airtight, that so that when the doors are closed, when the windows are closed, you've got really efficient heating and cooling. And don't forget, you're still getting the fresh air coming through the mechanical ventilation system. So it's not like you're suffering for having the windows closed. And what all that means is that Passivehaus keeps temperatures stable inside. You don't get hot or cold spots in the house or in the fabric, or there's no hot frames in summer or cold frames of windows in winter. And it's even air temperature throughout the house. And that prevents condensation and mold. Condensation forms where warm, moist air meets a cold surface. And there's no cold surfaces in a Passivehaus due to the insulation and the avoidance of thermal bridging effects. And what that means is that the surface temperature of any interior surface is very similar to the air temperature. And that means that the moisture can't come out of the air and hit a cold surface and form condensation. And in addition, the humidity is controlled. So relative humidity in a Passivehaus is controlled between 40 and 60% relative humidity, and it must not exceed 60% for more than 10% of the year. And that means mold can't grow, because mold can only grow where relative humidity is above 70 to 80%. And that happens a lot, you know, on the rainy days and on hot, humid summer days. We get relative humidity in summer well over 80% outside a lot of the time. And so a Passivehaus controls that humidity, and the surface temperature means, and a constant exchange of air through the heat exchanger and the mechanical ventilation with heat recovery unit means that you do not get condensation anywhere in a Passivehaus, and that means mold can't grow. So it's much healthier. And that also means the airtight membrane and the weatherproof membrane can shed water out of the fabric. If any water could get in, it can always get out. And what that means is you don't get structural damage from mold and condensation in your stud work either, which is actually a hidden structural problem in a lot of houses. It certainly was the case when we took the linings off the old house. We could see that there was rot and there was structural damage from moisture being stuck in the house. And normally houses rely on it just being leaky in order to ventilate that structure. But the more modern methods of construction can end up trapping moisture in the fabric. So Passivehaus solves that problem too, which means it's durable and a long-lived construction. There's a little cutaway behind the plasterboard. So you can see the plasterboard, the battens, you can see the airtight membrane, you can see an electrical penetration coming through the wall. We've got ceiling fans in every room to provide sort of the free cooling effect of air moving and cooling the skin through the evaporation of moisture from our skin. That free cooling effect we can exploit in summer, but we also do have an air conditioning system. We really did this because of heat waves. In summer, we're predicting, due to climate change, we're going to have weeks at a time above 35 and hitting 40 in summers when it's not a La Nina year, of course, in the El Nino years and the drought cycle. So we expect to use an air conditioner in heat waves, but we don't need it in a normal summer. We've got sunshades. You can see the grey external shades on the west keep the sun out of the windows on the west. We've got good insulation, we've got double glazing, and that keeps the house cool passively in summer. Plus we've got the ceiling fans. And if we need it, if it's really, really boiling hot outside, then we do have an air conditioning. It's a little 5.2 kilowatt multi-head split system, split AC unit. It's got one outlet in the living room, which is that top left picture, and the bottom left picture is the outlet in the rumpus room upstairs. And that distributes enough cooling and heating to the whole house that it will always be a stable temperature. And that means we don't have heating. We don't need it. We've got the reverse cycle air conditioner. We can do heating if we needed it, but we don't need heating. In a passive house, the temperature is always between 20 and 25, so you don't feel cold. They're designed to avoid the need for heating. Just people's body heat, the refrigerator, the solar gains that are carefully calculated and balanced mean that you don't need heating and you don't have cold kids, which is nice. And it's really efficient. For hot water, we've got a Sandon electric hot water heat pump. So it's a fully electric house, no gas. So the hot water tank runs off this heat pump system, which works a bit like an air conditioner in heating mode. It's dumping its heat into the tank. So you get cold water that gets heated using a refrigerant loop through the Sandon condenser unit there, which is the one with the flowers next to it in the diagram to the bottom, and then that delivers hot water into the tank that then delivers the hot water to your shower, etc. So it's a really efficient, and it's not using harmful refrigerant gases. It's using CO2 as the working refrigerant, so it's a really environmentally friendly system as well because there's no refrigerant leakage. This is the green roof. This is the build up of the green roof. So there's a membrane underneath. Then there's this sort of drainage layer that looks like sort of a milk crate type substance, the plastic at the bottom. Then there's a root mat to stop the roots going down into the drainage layer. And then there's the growing medium, which is the fluffy stuff that looks like insulation. And then there's soil on top, and that's the green roof. And it's got 5,000 litre rainwater tanks underneath as well, underneath the driveway, that is. You can see them being buried here. And the drainage from the roof and it comes into that and then is recycled for the landscape and toilet flushing, landscape irrigation system. And there you can see it finished. It's just one of the access hatches to the tank that's sort of integrated into the garden bed where we're growing a hedge. And this is the beautiful native Australian black butt timber flooring going down, which is just a beautiful feature of the house, really warm. We sort of chose the rustic effect where we've got the sort of more grain showing, which we really like. The stairs are black butt as well. We've got native Australian succulents primarily. I think there's only a couple of non-native species, maybe one or two on the roof, but the bulk of it is native Australian succulents. You can see a beautiful little blue tongue lizard there checking it out. But then the green roof got planted out. So we planted the plants there. They were supplied locally, and it's growing really nicely and eventually will form a really lush green layer when it gets fully established. All electric again, so we've got electric induction cooktop and stove, and this is the surface mounted drenches, so that when there's a bushfire, which of course there will be, and Ku-ring-gai National Park is up in flames and it's raining ash on the house, we can, it's pretty resilient building structure, metal roof and solar panels, and then the timber cladding is fire resistant to BAL 19 levels, but we've also got these surface mounted drenches which will wet the entire outside of the house if we need to evacuate. So it gives it a little bit more resistance, resilience to ember attack in a fire, which most people here will have experienced. It's pretty horrific. It's got native plants in the landscape, but it does have some food growing. So we've got fruit trees in the front. We've got an almond, an avocado, a mango, and a couple of mulberries, and then some orange and citrus, which is great. And it's established well. It's only a year in, but yeah, the garden's going really well. We love it. And it's got a robot mower as well. It's super cool out the back. So this mows the lawn and means that I don't have to do it, which is awesome. And it's kind of tucked under a little barbecue area at the back. This is formerly in the old house. We have this beautiful orange tree and food growing, and we've got chickens, and they're under the trampoline in that nice little convenient. They got a chicken house out the back, and we let them out, of course, but it's all fox protected there, which is good. And then we've got garden beds going around the edge, the perimeter. You can sort of see in the plan, there's perimeter garden beds around the edge of the backyard as well, where we've got herbs and, tubers and, asparagus and all sorts of things growing, which is great. And I built that cubby house for the kids, which is nice. You can see the chickens in the underneath the trampoline. And, I'm a beekeeper, so we had bees at the old house, but and we get sort of 50 kilos of honey a year, but we haven't got the bees yet. We've got the spot for it upstairs, but we haven't put them in yet. It's got Japanese toilets, bidet toilets, which is super cool. And then this awesome tap called a Felton digital smart flow tap in the master ensuite, where you just press the button and it gets to the right temperature and tells you how much water you're using, which is a super cool sustainability feature. And then this is our little second car, the electric cargo bike that we use to take the kids to school and daycare, and it's a recent photo. And of course, it's designed for accessible, which I mentioned at the beginning, but it's a step-free path from the street into the entry of the house. It's a level threshold, so there's no bump at the door. It's got wider internal doors and corridors. It's an accessible toilet on the ground floor. It's a hobbless shower, so there's no step at the edge of the shower. It's got reinforced walls, so you can install grab rails, and the stairways are designed to reduce the likelihood of injury. So there's 3 flights with landings, quite large landings. And so there's the level threshold at the entrance. There's the accessible bathroom, and there's the sort of ramp-based entry from the driveway into the front door with no steps that you can see there again. And there's the solar on the roof, 20 kilowatt solar, and my dog making an appearance. So it's the north facing pitch of the roof is completely covered in solar panels, 50 solar panels, it's 20 kilowatts of generation. And we were I think the third building in Australia to achieve, we're about the 38th house building of any type in Australia to achieve passive house of any kind, the third in New South Wales. And we were the first in New South Wales to achieve Passive House Premium, and only one of 17 in the world at the time to achieve Passive House Premium, that top level. And we were the first project in Australia to get the Green Star Homes certification. So there, I'm proudly displaying my certificates on the front door. And a bit of detail about the rating. So Green Star Homes and Passive House work really well together, because Passive House is sort of world's best practice, energy efficiency, windows and doors, avoiding thermal bridge effects, air tightness, and limiting the energy consumption, plus renewable energy, air quality, and moisture control, and then a really rigorous design and construction quality assurance process. And then in addition to that, Green Star adds efficient appliance controls about the light, materials credits, water management, and climate resilience. So they work really well together. There's a thing called a crosswalk, which shows how, if you get Passive House, how it helps with Green Star Homes, and likewise the reverse. And then a little refresher, that's Passive House. So good insulation, improved windows, mechanical ventilation system, airtight membrane, and avoidance of thermal bridge effects. And I went through this at the beginning, but it's a passive house, it's low waste, it's sustainable materials, water sustainable as well, and really healthy and comfortable. This was the team that built the building. Andy Marlowe on the left was the architect, Jamie Graziano on the right was the builder. Burkhart Hansen was the guy who manufactured the panels down in Victoria using a company called Carbon Light. Harley Trung and Jason Connell from Logic House supplied the high performance windows. Claire Parry was the certifier, the Passive House certifier, and Andy Picconi did the finance for us and got us the green loan. So, I mean, it was a great team of people to work with, and they did a really good job. We're super happy with the product. And I've written about it externally, and there's published articles, and there's YouTube videos of site walkthroughs and, time lapse, and, lots of LinkedIn posts with further videos and talking about it as well. So it's recorded, but those links, I'm happy to distribute this presentation, or you can contact me if you want the links. And there's just a few more architectural photos at the end. So that's the north facing front of the house, and the shed on the side, and your beautiful front yard. That's the back elevation with the big double doors open to the combined kitchen, dining and living room. There's the beautiful kitchen. It's it's beautiful. It's a nice new house. We're so stoked with it. And that's sort of the view from the kitchen to the dining and living space, the view out the big picture frame window, living space, and then the stairs with the sort of 3 flights and the 2 big landings to be more accessible. The bedroom upstairs with a beautiful east-facing high-level window, so we get the morning light, but not in our eyes. Automated blinds, and then that's the access window to get out and tend the green roof if you need to for maintenance, or to fix the AC unit or whatever if it breaks. One of the kids' bedrooms with the south-facing windows. This is the study. This is where I'm now at the computer on the right, seeing this beautiful north-facing study. And there's the details of the team who built it. So yeah, look, that's it from me, and we can get into some questions and answers. But thanks for sitting through what ended up being a bit of a long presentation, but hope you enjoyed it.
Excellent. Thanks so much, Chris. I know from this this point onwards, we'll field the questions for you, but just absolutely love that presentation. Very engaging, so inspirational. I'm looking through the questions now. Some of them are product specific. So if it's okay with everyone, I'll keep those ones to the side, just because as council, we don't necessarily promote particular products. But I know Chris has offered
alternatives to the ones I used. And so, you can find other manufacturers that do the same thing, membranes, insulation, windows. So yeah, the names that I've dropped there just happen to be the people who ended up building my house, but not an endorsement from council.
But obviously you've offered that people could contact you if they had specific questions. And I know from the chat, I can see that Sophie is actually in the process of building a passive house, and has had a lot of specific questions. So I've taken down her email for you. I'm going to start generally and then go into more specific stuff. And I guess if we run out of time at that point, we can answer frequently asked questions, just so we don't run over time, because I know this is the time when kids are going to bed and dinner might be on the table, and there's a few questions here as well about the presentation tonight. We'll definitely be sending it out, but I will ask that you fill in our Survey Monkey first to get the presentation, so that means that we get some feedback on how the presentation went, which is obviously awesome, and what you learned and what else we could do with this kind of information. So looking through, there's about 3 or 4 questions, Chris, on that decision to knock down, rebuild versus kind of a redesign of an existing structure, especially since there's a lot of heritage houses or uniquely designed houses in the area.
Yeah. Well, ours wasn't. And, it was a really old asbestos filled. It would have been quite problematic to refurbish it. It would have been possible, of course, but it was mainly that it was just too small. A really small old house, as they were built back in the 50s, that didn't really suit the needs of our growing family and I guess the aspirations of people today building new houses. And refurbishment ends up being very complicated. If you're pursuing passive house, you really would have to strip it back to the building fabric, put an airtight membrane on, a weatherproof membrane on, put the insulation in, put the airtight membrane on, make it airtight, and then put new cladding on, new roof, new windows. So by the time you do all that to an existing house, you want to really like that structure and keep it the way it was. And there are a lot of beautiful Federation style, frontages and things which are absolutely worthy of preservation. But that wasn't the case with ours. It was really lightweight timber structure that had lived a 60-year life, it had a good run for a pretty poor quality building, frankly. And it was largely timber. So that's, and as much of the materials from the demolition were recycled as possible. And what really matters in that scenario is the embodied carbon of what you replace it with. So if you replace an old lightweight timber house with a big new brick house, there's a lot of embodied carbon in the brick. But if you replace it with a Forest Stewardship Council certified sustainable timber, zero carbon timber, zero carbon cladding, actually there's not a lot of carbon implications around the materials, such that, it's always best if you can retain a building, but if you're going to knock something down, then you build a lightweight timber structure with certified sustainable materials, that's the best you can get.
Great. That's such a comprehensive answer. Thank you. One of the other big questions that has come through that I particularly like is, in this journey that you've taken, is there anything that you would have done differently, or is there some lessons learned that you'd like to share?
Everyone asks this to me, and I cannot honestly think of a thing I would change. I absolutely love this place. I spent 5 years planning it, and I was a sustainability consultant for many years. It's my job to do sustainable building, so I thought a lot about it. I applied all my professional expertise, all the architect's professional expertise, certified, builder. We all put our best into it, and for me, this is as good as it gets. It's just perfect. So no, I wouldn't change anything. We love it, and if you're thinking about doing it, go for it, because it's just great. It's a lovely lived experience. It's no energy bills, comfortable, great air quality. It's all the things that it promised, and we just love it.
Thanks, Chris. Another kind of big picture question. Where is it there? How do we help spread the word about Passivehaus and doing things better in terms of our houses? That's a really good question.
Yeah, I mean, I served on the board of the Australian Passivehaus Association for 5 years, and I was the chair of the board, which is a not-for-profit association trying to promote Passivehaus in Australia. It doesn't make any money. It's just trying to get the word out. So, I've tried to use my own house as an exemplar project to teach people about Passivehaus and, participate in events like this and spread the word and, open my home for Sustainable House Day. And, we do our best to try and get the word out, but you're right, it's not a well-known standard in Australia yet. Although there are over 600 certified Passivehaus professionals now, and there's more than 50 buildings built to this standard now. We're going to start to see some larger scale ones. There's 11 units in Redfern that have been built to Passivehaus. So it was one of the first large scale apartment blocks, and there's student accommodation down in Melbourne for Monash University, which is 150 bed student accommodation built to Passivehaus. So we're starting to see more of it and larger scale. There's a community hub. The city of Glenroy built a new library community facility to Passivehaus. And so we will start to see swimming pools, cultural centres, apartment blocks, houses. Around the world, there's every type of building, industrial buildings, fire stations, police stations, offices. Everything has been built to Passivehaus. There's more than 80,000 of them around the world. It's exploding in China, New York, Vancouver, UK, Europe. It's becoming, a really well-known worldwide phenomenon of, using the Passivehaus standard to be efficient, healthy, comfortable. And then on top of that, you can add green roofs and water efficiency and all the other good things, but it does the basics. It's super low energy, super comfortable, super healthy, and that's what Passivehaus is all about.
So I'm looking through now, Chris, and there's lots of very specific questions that are to do with, the amount of air coming through the house or windows, or why did you choose this thing or that thing. My suggestion is, given that it's now 8:15 and that we're sharing the presentation, that we obviously send out the presentation, people can review it, because I think you've actually answered pretty much all of those questions. There are some very sort of generic questions on, what could you do if you can't do a Passivehaus? And I'm happy to say that next week we do have a Comfortable Homes in Summer and Winter presentation with your energy friend, Adam Corrigan, to go through the little things that you can do in your own home if you're not quite at that stage to knock down and rebuild. I have my fingers crossed. I'd like to do a Passivehaus one day, but I'm not quite there.
But a lot of the same principles apply. You can have a ventilation system, you can do draft ceiling, you can improve insulation, you can have electric appliances, electric stove, no gas, and you've got a pretty sustainable house if you do those things.
That's exactly it. There's one really cute question I think I'm going to close on, if that's all right with you, Chris. Now, you've answered it, but I think it's a cute question that it's do you ever open and close the windows? So
Yeah,
obviously
yeah.
you can,
Yeah,
but
we
do
do.
you?
I think the big difference with Passivehaus is that you open and close the windows on days where it's fine outside because you want to hear the birds or you want to get a bit of a breeze. You do it because you want to, not because you have to. And that's the big difference, because you're always getting the ventilation. So you never feel like you have to. It's never stuffy. It's like, oh, it's raining, it's winter, it's cold outside, but I've got to crack the window because I can't stand it. It's too stuffy. You just don't get that problem. So yeah, I open the study window in this room every day. When it's sunny in the middle of the day and I'm working here, I have the window open like normal. But then when it gets cooler in the evening, you shut it and it's efficient, right? So that's really the thing about Passivehaus. You can still run it as a naturally ventilated building. It works from a natural ventilation strategy, and most people do continue to open the windows and close them. Probably not as much as they used to, because they're not doing it for ventilation, they're doing it just for pleasure. But then you've still got your fresh air and it's still efficient. So yeah, yes, I do.
Wonderful. Yeah, I quite liked that question. I'll just check in with my colleagues, Lana and Taryn from the library, if they had anything that they wanted to highlight in the questions. I think I've covered it, but just in case, it's always good to have a fresh set of eyes.
Yeah, no, I think you absolutely have it. Yeah, Chris, that was a fantastic presentation. Thank you so much. And like Susie said, we will send out the recording to everyone. It might take us a few days to get it out to everyone. But I also just put in the chat just some resources from every council that's been involved in this evening. Might be a little bit difficult just to see the links there, but if you just go to your local council website and just search sustainability, every single council that's been involved this evening has some fantastic resources and just really achievable things that you can start with until you're ready to build your own passive house. But yeah, that's it for me. Thank you so much, Chris, and thank you, Susie and Lana.
Thank you.
Thank you.
For your attention.
And thank you everyone for coming.
If we could quickly pop the survey in the chat, I think that would be wonderful, and then we'll bid everyone good night. And a massive thanks to everyone and to Chris for a fantastic presentation.